In the dark reaches of space, where time moves like molasses and galaxies spin like forgotten clocks, there is a star that should be dead, and yet it burns. This isn't science fiction. This is real. A cosmic rebellion, a flame that defies fate. They call it a zombie star, a star that went supernova, and then, somehow, came back to life. Let's begin where most stories end, with death. When a massive star dies, it does so in spectacular fashion. It collapses under its own gravity, igniting a violent explosion known as a supernova. In a moment, the star's outer layers are flung into space, and its core is either crushed into a neutron star or vanishes into a black hole. It's one of the most dramatic finales in the universe. But in 2014, astronomers witnessed something that shattered that narrative. A star named IPTF 14HLs, discovered by the Intermediate Palomar Transient Factory, hence the strange name, was located 500 million light-years away. It exploded in what seemed like a typical supernova. But then it kept exploding, again and again. Over the course of 3 years, IPTF 14HLs brightened and dimmed 5 times, like a cosmic heartbeat, like it couldn't decide whether to live or die. That's not supposed to happen. Supernovae are one-time events. Once a star goes out, it's gone. So what was happening? Let's step back. Our Sun is a stable, middle-aged star. It fuses hydrogen into helium in its core, releasing energy that balances the inward pull of gravity. But when the fuel runs out, gravity wins. The core collapses. The outer layers fly off. That's the end. But stars like IPTF 14HLs are monsters, possibly 50 times the mass of our Sun. And when you're that massive, the rules start to bend. Some scientists believe this star was so large that its core underwent pulsational pair instability, a rare and violent process. Here's how it works. Inside a massive star, the temperature gets so high that light itself starts creating matter, pairs of electrons and positrons. This change in pressure causes the core to briefly collapse, triggering a massive explosion. But instead of dying, the star survives. It ejects a layer of itself into space and stabilizes. For now, then it does it again and again. Each eruption like a scream, each flare-up a refusal to fade. For 3 years, this zombie star lit the sky with flashes of ghostly brilliance. And it might not even be done. It's like watching a phoenix not just rise from ashes, but never turn to ashes in the first place. And in the cold, silent dark of the cosmos, this defiant firestorm captured the imagination of scientists and stargazers alike. But why does this matter? Because it challenges everything we thought we knew. Our models of stellar death are built on decades of physics, on math, on light curves and core collapse theory. But this broke the model. And in doing so, it reminded us the universe still has secrets. Perhaps IPTF 40HLs is not alone. Perhaps there are other stars out there, flickering in defiance, rewriting the rules of life and death. Maybe some stars don't die because the story isn't over. Maybe some flames are too stubborn to extinguish. And what a metaphor that is for us. How many times have we felt on the edge of collapse? How often do we think we've burned out only to rise again, not because we're invincible, but because we refuse to be extinguished? The zombie star isn't just a mystery of astrophysics. It's a mirror. It shows us the power of resilience, the beauty of unpredictability, the grace of refusing to obey the script. But let's go further. This isn't the only example of a star defying death. Astronomers have found other stars with strange light curves, unusual behavior suggesting eruptions before final collapse. Some scientists believe these may be part of a new class of supernovae, where massive stars end in multiple violent outbursts, like cosmic symphonies, each movement building to a final crescendo. The story of IPTF 14 Hills echoes through astrophysics. It forces scientists to revisit equations, to challenge assumptions, to ask bigger questions. What really happens when the most massive stars die? What's the role of dark matter, magnetic fields, or even quantum effects in shaping a star's fate? Could these zombie-like phenomena hint at physics we haven't yet discovered? And if a star can do the impossible, what else might the universe be hiding? We often think of space as cold, mechanical, predictable, but the truth is it's wild, alive, unruly. And sometimes it reminds us that life, whether stellar or human, is not always linear. Sometimes it pulses, sometimes it resists, sometimes it refuses to go quietly. Astronomers are still watching IPTF 14 Hills, waiting, wondering, hoping for another flare. Because in its pulses we see more than data. We see defiance. We see hope. We see that in a universe ruled by entropy and endings, there are still stories that stretch beyond the edge. And this star, this impossible undead star, is one of them. So the next time you look up at the night sky, know that somewhere out there is a star that exploded and then kept going. A flame in the dark that said, "Not yet." And maybe, in your hardest moment, when the world tells you it's over, you'll remember that too. Some stories don't end. Some stars refuse to die. Thank you for watching Explore the Bright Side. If this story lit a spark in you, share, comment and subscribe. Tell us, what makes you refuse to quit even in the dark? Because maybe, just maybe, the fire in you is older than stars.